According to the UK fuel poverty strategy, a household is said to be in fuel poverty when its members cannot afford to keep adequately warm at a reasonable cost, which means 21 degrees Celsius in living room and 18 degrees Celsius in other rooms, and they spend 10% or more on households' total income on fuel. Fuel poverty is a very serious problem in countries like UK, Ireland, and New Zealand. Take UK for example. The chart shows the number of households and percentage of population of the country that is suffering from fuel poverty in recent years, from 2003 to 2014. Although we can see a declining trend of percentage, a 10% to 11% is still very high. It means at least 1/10 of the country had to choose more basic survival needs like food and give of warmth to stay alive, and thousands of people get sick and die because of fuel poverty.
We listed three main solutions to deal with fuel poverty, which are lowering fuel price, boosting heating efficiency, and improving insulation in houses. While the first two solutions might require too many changes or investments, improving insulation seems most accessible and affordable to low-income families. Let's look into the insulation problem. According to the first law of thermodynamics, we have the formula here to simulate a house. Regarding the rigidness of house and our goal to keep temperature, the formula would be simplified into Q in and Q out. While Q out is the heat escaping the house, our heater needs to provide an equal amount of heat as Q in. Therefore, reducing Q out directly means saving the fuel or money to run the heater.
To insulate an area means to protect that area with a certain material so that it will keep the same quantity of heat inside. In reality, this protection is more complex than it seems because heat can go through objects. This is what we call heat leak. Thankfully, there are known materials that have the distinct property of letting heat escape. These materials are known as insulators. Insulators have a special value given to them that is named the R value. As you can see from the following formula, the R value is reversely proportional to the heat transfer, meaning that the higher the R value, the less heat transfer. This R value helps us find a good insulator that is appropriate for the job.